welcome. Let's try to solve another Leetcode problem. 1301, number of paths with max score. So for this problem, let's try to make a drawing to understand the problem. So let's just use the first example to make a drawing. So we have a board. So this is our board. So we have 3 rows and 3 columns. So it's going to be like this. And the first one is going to be E and 2, 3. And then we're going to have 2, X, and 2. And so for the third row, it's going to be 1, 2, and S. So this is just according to the problem. We have such a board, and we're going to start from this 3S, or this character S, and we want to reach the character E. So this is the start, and this is the end point. And from the start position, we can go up, and we can go to the left, or we can go to the up left. So this means that there are going to be 3 directions for us to go from the start to the end. But we want to return 2 numbers. It's going to be a 1D array, but it's going to be 2 numbers. So the first number is going to be the maximum sum paths. And the second number is going to be the number of paths for this maximum sum paths number. So for example, currently we're going to return a 7. So this 7 is coming from this S to 2, 3, and 2, and E. But while we are starting from this S, it is a 0, 0 plus 2 plus 3 plus 2 plus a 0. While we reach this character E, it's going to be a 0. So the total sum is going to be 7, and this is going to be the maximum. Because if we reach this X, it's going to be an obstacle, and it's going to be 0. So for example, this is a 2. So while to reach this X, definitely it's going to be a 0, or we can set it as a negative value. It depends on us, but definitely there's no path. But while we reach 2, 3, 2, and E, so the maximum sum is going to be 7. But if we go to the left side, it's going to be 2, 1, 2, E. It's going to be 5. But we need to return the maximum value, so it's going to be 7. And how many paths? It's going to be 1. So this is why our return is going to be 7, 1. So if the problem like this, normally the problem. But for us, we're going to use DFS with memorization to solve it, because this is much easier to understand and to code. So let's just use a simple example maybe. So maybe let's just use a very simple example. So according to the problem, the length of the board is going to be at least 2. But for presentation, we just prepare a simple example to explain why it works. So for example, this is E. We're going to start from this, this is S, so we're going to start from the S. So this means from the S, we're going to set a value. So we're going to set 0. So this is just the starting point, and this is the finishing point. So this is the E. So we are starting from this S, it is at the bottom right corner. So from here, we have a record of how many, what is going to be the maximum of sum paths. So we're going to set it as 0, because from the S, we are starting from S, it is going to be 0 according to the problem. And how many paths starting from S? It's going to still be 0, because currently we are not sure if there's an answer or not. If there's no answer, so we're going to return 0 and 0. Now we're going to start in to the top left or the top left side. Maybe here we have a value. So for example, from at this place, maybe we have a number of 2. At the left place, maybe we have a number of 3. So what's going to happen is that if we reach to the top side, so if we go to the top, so the accumulated sum is 2 plus 0. 2 plus this 0, so it's going to be 2. And if we go to the left side, it is 3 plus 0, it's going to be 3. But how many paths? So there will be 1 path, because if it go to the top, it's going to be 1 path. It's going to be 2, 1. And here, let me just clean up a little bit. So at the left side, it's going to be 3, 1. So this means at this means at the left side, at this cell, the maximum value is going to be 3, and how many paths? It's going to be 1. At the top side, at this cell, So the maximum sum is going to be 2, and the number of paths is going to be 1. Yeah. But whatever return, we're going to return the maximum path sum. So we're going to return this cell. But we didn't reach to the end. We have to reach this cell. But what happens for this cell? So for this cell, we're going to choose the maximum value because this is 3. 3 is bigger than 2, so we're going to choose a 3. And how many paths? It is 1 because the maximum number of the paths is going to be 1. So we're going to return this 3 and 1. So this is going to be our final return. So we're going to return an array as 3, 1. So the maximum value is going to be 3 and the number of paths is going to be 1. Yeah. But let's just use another example. Maybe it's easier to understand what happens for here. But what if this value is 2 instead of 3? Yeah. So if this value is 2, so the maximum sum paths to the left position is going to be 2, and how many paths is going to be 1. And what about the top? It's going to be 2 and 1 as well. So now, what happens for the top left corner for this cell? This is our adding position. Yeah. Because this number 2 equals to this number, we want to choose the maximum number. So for example, we're going to choose the maximum number, it is 2, and there's a path of 1, and then we find another cell. There's another cell, so the maximum number is 2 as well. So this means we're going to accumulate the path sum. So this one going to plus this one, so the maximum sum going to still be 2, and the number of the paths going to be 2. 1 plus 1 is going to be 2. Yeah. So this is going to be our final return. So the maximum sum path is going to be 2, and the number of paths for this maximum number is going to be 2 as well. So this is our final return. Yeah. So now I think it's really clear how we can start the coding for this problem. So we're going to use a DFS. Yeah. So this is our this is the edge cases. So we're going to start from the 0, 0, start from this position 0, 0, and we're going to search until we reach the bottom right corner this position. If we reach the bottom right corner, and we're going to return 0, 0. So this means the maximum sum path is going to be 0, and the number of paths is going to be 0. Yeah. And according to this DFS with memorization, basically we can calculate all the cells with the two values, maximum sum and sum paths, just with O(n) squared times complexity. But the n gonna be 100 according to the problem. This means by O(n) squared we can solve the problem. So this is gonna be a DFS with memorization problem. Yeah. Now let's try to solve the problem. So let's just prepare a mod. It's gonna be 10 to the power of 9 plus 7. And we should also be careful about this 10 to the power of 9 plus 7, this modular value. It is only used for the second one. Yeah. It didn't tell us we can use this modular for the first value, the maximum number. But we need to use it for the second number. Yeah. This is for the mod. This is according to the description. So we're going to return the first integer. It's going to be the maximum sum of the numerical characters. Yeah. We can collect. And the second number going to be a set of paths. How many of the paths for this maximum sum? And we need to take a modular. Yeah. This is for the second value. And let's just design this problem. So we're going to design a dictionary, and we need to turn the numbers. We need to find the numbers inside of the string, and we're going to prepare a dictionary. So it's going to be string I with I for I in range 10. So this means inside the board, if we find a string 2, we're going to turn this string 2 to a number, because we need to we need to calculate the maximum sum of the numerical characters we can collect. So this is a 2. If we find another 2, it's going to be 2 plus 2. So this is why I'm going to design a dictionary. So for the string 2, it's going to be a number 2. For the string 0, it's going to be a number 0. So for the string 9, it's going to be a number 9. And then let's just design the start and the end position. So for this DE, we're going to prepare a 0. But if it is a DS, it means the start, we're going to prepare a 0. but what if it is obstacles the x? So we're going to set it as negative infinity. So for the negative infinity inside of the DP problem, normally means this is unreachable. We can never reach this position, so we're going to set it as infinity. So if we return at infinity, this means we can never reach that path, so we're going to return a 0 and 0. So this is why we designed the dx like that. Let me also prepare a variable n. It's going to be the length of the board. Yeah, as the board length and the board I length are going to be equal, so we just need to prepare one variable n. It's going to be enough. It's going to be a square for the board. So we're going to define a DFS function. So let me prepare a class with the DFS. So the DFS is going to be start from the top left corner. So I'm going to record the final result as DFS with 0 and 0 because I'm going to start to search from the top left corner until I reach to the bottom right. And finally, I'm going to return the final result. Yeah, so I will return it later on, but I will write the DFS first. So the condition is if r equals to c equal to n minus 1. So this means according to my explanation, I'm going to return a 0, 0. So this is just the edge case. So we're going to, yeah, from if we reach this bottom right corner, we're going to prepare a 0 and a 0. Yeah, while we are using the DFS for the for solving this problem, actually we are doing from the top down. But for actually running of the DFS, actually we are going from the bottom up. So this is why we're gonna, yeah, because for the function stack, we're gonna start from here, and then we're gonna just go up. But while we are calculating, it seems it is top down, and we should understand why we're gonna, yeah, use this return for 0 and 0. Now let's prepare a result from here. From the beginning, we're going to set a negative infinity, and the number of paths is going to be 0. And then we're going to update this result according to how many paths we have. Yeah. So we can go to 3 directions. So for row and column inside with r plus 1 and c plus 1. So this, let me first write it and then explain it. So it's going to be r with c plus 1 and r plus 1 with c. Yeah. So for row and column inside the 3 directions, so this basically means, so if this is my r and c, row and column, I can go to 3 directions. Yeah, right? So I can go to the right, and I can go to the bottom, I can go to the bottom right. Yeah. So for our problem, we are going to reach from the bottom to the top. Yeah. But while we are running the DFS, actually, we just need to reverse it. So this means from this cell, we want to find the value to the right, to the bottom right, and to the bottom. So this is why we're going to use r plus 1, c plus 1 is going to be here, and r c plus 1 is going to be here, and r plus 1c is going to be here, because all those values have already been calculated for us, so we're going to use it directly. Yeah. Now, I want to check if it is inside the boundary or not. Yeah. So if the row and column inside the boundary, I'm going to prepare a value next. I'm going to record it as the DFS row and column. Definitely I can calculate this value. So this next is going to be one of the 3 values, this value, or this value. But it has to be calculated, because according to the DFS, those 3 values should be calculated. So we can use it directly, and we can compare. Yeah. So if the result is 0, so this means the maximum sum of the paths. It is from here, negative infinity. So if this is less than the next 0, so this means we find a maximum number. So we're going to record it. But we need to record 2 numbers, not only the maximum number, but also the number of paths for this maximum number. Yeah, so this is one condition. If result 0 can also equal to the next 0. And in this condition, we just need to accumulate how many paths. So it's going to be result 1. But for this one value, we need to modular a mod. Yeah. So we're going to accumulate like result 1 plus next 1. But we need to modular this mod. According to the description, we need to modular this mod. Now, we calculated the this result. This result is we defined it from here. Now we updated the value, but for finally we still need to accumulate the final value that is coming from the result. So currently we get the value from here, here, or here. We choose the maximum value maybe, and then we need to accumulate this value. Maybe from here there's a value of 2. Yeah, maximum value maybe here. Not the maximum value. Maybe here there's a number. For example, the number gonna be 2. So we're gonna accumulate this number. Yeah. So finally we need to accumulate the final number from the R and C. Yeah. So the result 0 gonna be accumulated with the dictionary of the board. We're gonna find this number. It's gonna be R and C. Yeah. So in this way we updated all the values, and we just need to return the result. Yeah. Yeah, I think that's all about it. It is a little bit long for a DFS, but I think it is okay, because according to the problem we have to prepare this kind of a if and elif tag. If we find the maximum value, it is okay. We're gonna update the value and the number of paths. Yeah. But if it is equal, we need to accumulate it. Yeah. So this is I think this is the most important part of this problem. Yeah. Now we can return the result. So if result 0 not equal to -infinity, this means we find a value, so we're gonna return the result. Otherwise, we're gonna return a 0 and 0. This means we didn't find it, because according to the problem, the length of the board is gonna be at least 2. So this means such kind of coding should be okay. Now let me just run it to have a check if it works. It didn't work, so it's going to be 7-0. It's going to be 7-1, but I return a 7-0. Let me just check what is wrong with it. Yeah, I think from here I need to return a 1, because while I'm explaining the problem, I didn't explain why there's one path. So from here, the design is gonna be a 0, 1, because if we can reach this number as, definitely it means we find a path. Yeah, so we're gonna set at 0, 1, and then here gonna be 2, 1, and here gonna be 2, 1 as well, and here gonna be 2 and 2. So I think my definition is not right. Yeah, because for this number, maximum number currently it is 0, but if we can reach this cell, we need to set it 1. Otherwise, the number of paths is going to always be 0, as we can check from this example. It is always 0. There's no meaning, because we need to return the number of the paths. Yeah. So now, let me just run it again to check. Now, as you can see, it works, because our edge cases is right. Yeah, because at least we should have a path. If we reach to the end, we need to have a path of 1. So now, yeah, so if the value equals, we're gonna accumulate the path. If we set it to 0, and all the paths gonna be 0, there's no meaning to calculate the path. Yeah, so we need to set it as 1. This means we find a path. Yeah. Now let me just submit it to prove that it works. Yeah, as you can see, it works. It is a little bit slow because this is basically DFS with memorization. For Python, while we are using the cas, it's like a dictionary. It really takes the time. That is why it is so slow. But I think it is still okay for such kind of problem. And the time complexity is going to be O(n) squared, because we only used the R and C, and inside we didn't use any loop. And for this loop, it is still okay because there's only 3 directions. So the final time complexity is going to be O(n) squared. And the space complexity is going to be O(n) squared as well, because we used the cas. Yeah, I think that's all for it for this problem. Thank you for watching. See you next time.